All right, for this next example, we are going to prove Theorem 1, which is what the derivatives of arc cosine and arc sine are. Again, these are just inverse. What's the derivative of inverse sine and derivative of inverse cosine? For this video, I'm only going to show how we get the sine inverse because it's exactly the same procedure as the cosine inverse derivative. So it's really only worthwhile to see the one in video form. The type or the written notes have them both shown. Okay, so let's go ahead and figure this out. So our goal here is to figure out what the derivative of sine inverse is. So our goal here, let's just write this out, is to prove that the derivative ddx of sine inverse of x equals this thing. Okay, so how the heck are we going to do that? So let's go ahead and say, let's let y equal the sine inverse of x. Okay. So then, ultimately, we want to know the derivative of this. So ultimately, we kind of just want to find what dy dx is. If we know what dy dx is, that should tell us what the, it should be this right here. But we don't really know how to, we can't just take the derivative of each side like this because we don't know what this is. We're trying to show it's this. So we can't just take the derivative here and use this fact. We want to somehow arrive at that. So instead, let's go ahead and take the sine of each side. And then when you take the sine of the sine inverse, they are inverse functions to one another, so they will mutually annihilate one another, and we'll be left over with just the argument, the input, x. So now, in this format, we can actually differentiate because we do know how to take the derivative of sine, and we do know how to take the derivative of x. So the derivative of sine is just going to be cosine of y, but because we're differentiating a y with respect to an x, we're going to need to tack on this dy dx term. And then the right-hand side's derivative is just 1. So now let's solve for dy dx. So dy dx is 1 over the cosine of y. Okay. So what we really want to do here is not have, if at all possible, whenever it's possible, after you solve for dy dx and you have some expression here, sometimes it's easy to get rid of this y and write it in terms of just a single variable x. So if we do that, this would become dy dx equals 1 over the cosine of y. And what's y? Y is equal to the sine inverse. Okay. Crazy. So that's one thing we can do. But to really make this look nice, there's a little thing that we've done in the beginning of the semester, and we're going to use it right here. Whenever you have a trig function nested with another inverse trig function, not necessarily the same, right? It's not cosine and cosine inverse, it's cosine and sine inverse. They're both trig functions. One's the, let's just say, quote-unquote, regular trig function. The other one's the, quote-unquote, inverse trig function. They don't match the right type, though. So whenever that happens, there is a nice way that you can rewrite it without using sine or cosine. So let's, for a moment here, go back a step and just look at this cosine of y term. All right, so ultimately we want to know what the cosine of y is. Let's look at this right here. Sine of y equals x. So remember that sine as a ratio is opposite over hypotenuse, SOHCAHTOA, right? So for us, this means the angle Angle? Angel? I always mess that up. The angle is y, and the ratio of opposite over hypotenuse is this, x over 1. So on a right triangle here, we can just put our angle y someplace, and now relative to this angle y, opposite of it is x, hypotenuse is 1, and then using Pythagorean theorem, we get the adjacent side length as that. So now, what is the cosine of y? Cosine of y is just adjacent side length over the hypotenuse side length. So this implies that the cosine of y is the square root of 1 minus x squared all over the hypotenuse of 1. So just that. So now we can come here and use the following. dy dx equals 1 over cosine of y, but what's cosine of y? Cosine of y is this square root. Same exact procedure works for the derivative of arc cosine.